Okay, so let's have a look at the 2021 Leaving Cert Higher Level Maths Paper 2, question 10. People with O negative blood type are called universal donors because their blood can be given to anyone else. In Ireland, approximately 8% of the population have O negative blood. At a blood donation clinic, 10 donors give blood, one after the other. Find the probability that the 10th person is the third O negative donor. Give your answer correct to 4 decimal places. Okay, so this is a Bernoulli trial again. It's an extended version of the Bernoulli trial. So let's just write down our probabilities here. So the probability of being O negative is 0.088%. So the probability of not being O negative is going to be 0.92. So we want to find the probability that the 10th person is O negative. So this is going to be our P, this is going to be our Q. So probability of success, probability of failure, if you like. Now, the extended version of this means that the 10th person is going to be O negative. That means we need, within the first 9 people, we need 2 people to be O negative. So we need to look at 9 choose 2. Probability of success is 0.08. We've got to raise that to the power of 2. This is the OR here. And then 0.98 to the power of 9 minus 2, which is 7. So this is the first 2 people within the first 9 being O negative, and then the third person has to be the third person who is O negative has to be the 10th person who donates. So that would be 0.08 out here. So this is our probability. So this is calculator work again, so we have to do this to 4 decimal places. So you should get, when you do that on your calculator, 0.103 to 4 decimal places. Okay, so that's part A1. Let's have a look at part A2. At a blood donation clinic, 5 donors give blood. What is the probability that at least one of the 5 donates O negative blood? Give your answer correct to 4 decimal places. Okay, so the probability that at least one donates O negative that's going to be equal to 1 minus the probability that no one donates O negative blood. So let's have a look at that then. That's going to be 1 minus, we're going to do 5 choose 0. No one is donating O negative blood. The probability of having O negative blood is 8%, so that's 0.08, and that's going to be to the power of 0. And then you've got the probability that you don't have O negative blood. That's going to be 0.92, and that's to the power of 5 minus 0, or just 5. So when we work that out, we get 1 minus, and it is 0.659, 08152, 32. When you work that out to 4 decimal places, you get 0.3409. That's to 4 decimal places. Find the minimum number of blood donors required so that the probability that at least one of them is type O negative is greater than 0.97. So at least one of them, again, is going to be 1. It's going to be 1 minus the probability that none of them donates blood, O negative blood. So we don't know the number at this stage, so we're going to look at n choose 0. It's going to be 0.08 again to the power of 0, and 0.92 to the power of n minus 0, which is n. This is our probability, and we want that to be greater than 0.97. So we've got to work out what n is in this particular case. Okay, so the first thing I think I'll do is just get rid of that 1 there. So we'll end up with a minus on this side. Now remember, n choose 0 is just 1 and 0.08 to the power of 0. Anything to the power of 0 is just 1. So really on this side we just end up with 0.92 to the power of n. On the right hand side, subtract the 1, you get minus 0.03. Let's just get rid of those minuses. 0.92 to the power of n. It's going to be less than 0.03. We've multiplied across by minus 1 here, so you've got to switch around the sign. So next thing, you just get the log of both sides. So get the log, we'll use natural log here, you don't have to. 0.92 to the power of n less than log 0.03. Bring the n down, so that gives me n log 0.92 less than log 0.03. And finally then just divide by log 0.92. Now remember, log of anything less than 1 here is going to be negative, so again you've got to flip that around. So you end up here with n is greater than log 0.03 divided by log 0.92. So when you work that out on your calculators, you should get 42.05. Now we want n to be greater than 42, so that means n here is going to be equal to 43. So this is my answer here. We were asked to find the minimum number of blood donors, so we have to be looking at a natural number here. So that's it, n is equal to 43. Let's have a look at B here. So this is a different type of question. We have a homeowner has a problem with the heating system in her house. A plumber has identified the problem as a faulty part. The homeowner knows that 80% of cases, in 80% of cases, a repair of the part will fix the problem, and this repair will cost 70 euros. If the repair does not work, then a new part will have to be bought costing 150 euros, and there will be an additional labour cost of 80 euros to replace the old part with the new. Find the expected value of the cost of fixing this faulty system. So the probability that the repair will fix, so the probability that the repair will fix the problem is 0.8, and that's going to cost 70 euros. So that's going to cost 70 euros. Okay, so we have to find the expected value of the cost of fixing the part. So we're looking at if the repair doesn't work, then a new part will have to be bought for 150 euros and an additional labor cost of 80 euros. So what we're going to look at here is the expected value. The expected value is going to be the probability of it working multiplied by the cost, and then we've got to add the probability of it not working, which is 0.2, by the cost of it not working. Now the cost of it not working is going to be 150 euros plus 80 euros, so that's 230 euros. The expected value here then is just simply going to be 102 euros. And that's it for part B. Okay, so let's have a look at part C. A life insurance policy pays out 120,000 euros if the policyholder dies and 40,000 euros if the policyholder becomes disabled. The insurance company has calculated that in general in any given year the probability of death is 0.0001 and the probability of a disability is 0.002. The company has 18,000 policyholders on its books at present who are all charged the same premium. The company's goal is to make 900,000 euros profit in any given year. Find the annual premium it should charge its customers, which in an average year would generate this level of profit. Okay, so we've got to look at the expected values here again. So let's look at the expected value of a death or an injury here. So we're going to look at 0.00, how many zeros are in this? 0001. Got to multiply that by 120,000. That's the probability of someone dying multiplied by the payout. And the probability of someone being disabled then is 0.002 multiplied by the payout, which would be 40,000. So this is our expected value. Now, when you do that, you should get 92 euros. This is the amount of money you would on average expect to pay out to policyholders. So there are 18,000 policyholders, so let's take the 18,000, multiply that by 92. So when you do that, you get 1,656,000 euros. So this is how much you would expect to pay out to the policyholders. Now we want to, this company rather wants to make 900,000 euros profit. So I'm going to take the 1,656,000. I'm going to add the 900,000. That will give us 2,556,000 euros. And finally then I'm just going to divide that by 18,000 to see how much we would charge each policy holder then each year, what their premium would be. So you take 2,556,000, divide that by 18,000, and that gives a premium then of 142 euros for each customer. Now you can check that if you want. If you take the 142, euros, subtract the 92 euros, which on average you would expect each customer to be paid. That's the expected value here to be paid out. You get 50 euros. So there's a 50 euros difference between what you would expect to pay out and what the customer is paying in. Now if you take the 50 euros and multiply that by the 18,000 customers or policyholders, you will get 900,000 euros profit. So that's it for this question and indeed paper 2 and the 2021 Leaving Cert.